All right, Algebra 1, Unit 7, Lesson 6, Rewriting Quadratic Expressions. So, puzzle of rectangles. Here are two puzzles that are involving side lengths and areas of rectangles. Can you find the missing area in Figure A and the missing length in Figure B? So, can you find that? And can you find that? We actually do that in consumer math for blueprints for houses. All right, so go ahead and try that. Pause the video and try to find these missing pieces. All right, so hopefully you paused the video and you try to figure out these missing pieces. Um, One of the things that you should notice is you have plenty of information to go off of. All right, there's several of these dimensions. You notice, for example, just by looking here, I notice I have this piece of information, right? And I have this piece of information, which kind of gives me an idea about this length, right? So what's the whole thing is 8 inches, right? But the square above was just 8. So that means you have 2 inches just right there, okay? Um, Now, looking at the other piece, 'cause we're talking about square inches, that means we need to know all our dimensions, all our sides. Now, I know that this is 5 and this is 3. That means this piece right there has to be at least 2. Does that make sense? Because 5 minus 3 is 2. Okay. Um, but we actually need to know this whole length, right? So we have the 2. What about this piece right here? And hopefully you realize that squares are or have congruent opposite sides. So this is 8 inches here. So 8 plus that 2, right, is 10 inches. So 2 times 10, right, because length times width, and you should get 20 square inches for that piece. So now that I give you at least figure A, go ahead and try to figure out um, figure B. Okay, try to figure out how many inches that length needs to be. Okay, so something to notice, 36, we're talking about length times width, right? So length times width, that gives you 36. Um, so we know that this whole piece, let's use the highlighter, it really does help break things down. We know this whole piece is 12 inches, right? This piece is 3 inches. This whole piece is 11 inches. Okay. Hmm. Let's see. This is a tough one for sure. Let me think about what times what gives me 36. All right, length times width. I know 1 times 36 would give me that. I know 3 times 12 would give me 36. I also know 4 times 9 and 6 times 6, right? Um, if these pictures or images are proportional, it definitely can't be 1 times 36, right? This building or this piece right here is just not that skinny enough. Maybe it's 4 by 9. Okay, maybe. Uh, just proportional, because 6 by 6 would be a square, right? 3 by 12, that would still be pretty long, because like this is 3, right? This looks like a little bit bigger than 3, right? So I'm thinking 4, and if that's 4, this has to be 9. So that would be my best bet, all right? Just because I'm assuming that this puzzle is proportional. That means the lengths that you see there, are proportional to one another in terms of the inches. Okay, so you could have also thought about maybe what times what gives me 48, but we really needed to figure out this rectangle to get our answer. So I think the way I approached it with the what times what gives me 36, probably the most efficient way. Okay. I was trying to figure out if I could use the sides for the box down here, but I was like, doesn't really work out too well to our advantage because we don't really know what this piece is. To figure out what this piece is, right, and then do some subtraction. So we didn't really have enough to go off of for that one. Okay, so using diagrams to understand equivalent expressions. So use a diagram to show each pair of expressions is equivalent. All right, so uh, let's do this. Um, we know, so diagram, okay? So for this one right here, we know that x is going to be multiplying to or distributing to the x plus the 3, right? So we know that x times x is x squared, and x times 3 is 3x. That's basically what they're saying to do for each one of these. So go ahead and just draw a diagram to explain the other 5. And it's very much just drawing what I just drew, okay? So I'll tell you what, I'll do this one over here, just because that's a little bit more interesting of a one to do. So we have x plus 10, right? Uh, times x plus 4. X times x is x squared. 10 times x is 10x, and x times 4 is 4x, and 10 times 4 is 40. I can combine the x's, right? So that's why you get the 14x. It's a good way to double check. So you get x squared plus the 10x plus the 4x, which is 14x, plus the 40. So go ahead and do the other 4. All right, hopefully you did those. All right, so all we're going to be doing is completing this table. Go ahead and try to complete it right now. Um, go ahead and pause it. All right, so hopefully you paused it and you tried it and you just press play, right? So um, we know that we are multiplying the x times the x plus 7, right? So standard form, it would look like this, right? If we were to go backwards, let's see, it would have to be x, because both of them have x, right? And x plus 9, right? So go ahead and try to complete this table, all right? And see what you get. Okay, so hopefully you paused it and you tried this, and you realize you get x times x minus 8 over here. For this one, you get x squared plus 8x plus 12, right? And that's using the diagrams. You could always use the diagrams um, because I know x times x is x squared. X times 2 is 2x. 6 times x is 6x. 6 times 2 is 12. The x's are combined to give you that 8x. All right, this one's a little bit more interesting. All right, so what times what gives us 12, but has to add up to 13. We know x times x gives us the x squared. We know that 12 times 1 gives us 12, but also 12 plus that 1 would work if you were to combine them after you multiply the x's to get 13x. Okay, you could always draw a diagram for that to see that. Okay, so you could always do the diagram if you need to see that. So x times x x squared, and you get 1x, right? And you get 12x, then 12, combine the x's, and you see that 13x right there, okay? All right, so go ahead and finish the rest of the table. I highly recommend that for you. At the very end, all you're really doing is x uh, plus or minus some number, right, times x plus or minus, depending on the negativity, of some other number, right? So this is the actual rule, and you can use that to help finish the rest of the table, okay? So go ahead and finish the rest of the table. All right, so that's the end of the lesson. Have a beautiful day.